Good morning, everyone. My name is Yasmin Galali. You can call me Jasmine. I'll be your lecturer this semester for the course Human-Centered Requirements and Design. This course provides a foundation HCI covering a range of core topics needed to be able to model, design, implement, and evaluate usable software systems effectively. You will learn essential knowledge and methods for understanding users, designing systems and interactions that are effective, efficient, and satisfying to use, and evaluating the usability of these systems. Today's lecture is about user-centered requirements engineering. The objective of this chapter is to introduce you to the idea of user-centered requirements engineering. In previous courses, such as Introduction to Software Engineering, you were introduced to the software development methodologies, where all of them has requirements engineering as a stage of the software development process. Today, we are going to discuss how we as software engineers may make the utmost benefit of requirements engineering by applying HCI methodologies to this process. The ultimate goal of applying HCI techniques to software development practice is to achieve a usable and efficient system. Let's see why usability matters and what usability truly is. There is a general assumption in software quality management that the system will be tested against its requirements. Software quality is not just about whether the software functionality has been correctly implemented, but also depends on non-functional system attributes. The subjective quality of a software system is largely based on its non-functional characteristics. This reflects practical user experience. Literature suggested that there were several important software quality attributes. These attributes relate to the software dependability, usability, efficiency, and maintainability. For the interest of our topic, we will focus on the usability attribute. Usability is defined as the extent to which a product can be used by specified users to achieve specified goals with effectiveness, efficiency, and satisfaction in a specified context of use. Usability is a measure of how easy it is to use a product to perform prescribed tasks. Looking at the design of this picture, it's not intuitive for many people. If you look at the arrows with a horizontal perspective, you will turn right to go to room 101. But if you look vertically, you will turn left. Usability is defined by 5 quality components: learnability, efficiency, memorability, errors, and satisfaction. Learnability means how easy is it for users to accomplish basic tasks the first time they encounter the design. Efficiency: once users have learned the design, how quickly can they perform tasks? Memorability: when users return to the design after a period of not using it, how easily can they re-establish proficiency? Errors: how many errors do users make? How severe are these errors and how easily can they recover from the errors? Satisfaction: how pleasant is it to use the design? Speaking about satisfaction, it's important here to learn the difference between two terms that are widely used in the HCI literature: usability and user experience. User experience is a broader concept. It's more about the feelings of the user while using the product. User experience is not about good industrial design, multi-touch, or fancy interfaces. It's about transcending the material. It's about creating an experience through a device. Here in this doodle, we see a product, a bicycle, with easy interface elements that help you use the product, meaning riding the bicycle. User experience is about how the user feels when using and interacting with the product. User experience is subjective in nature because it's about individual perception and thought with respect to the system. User experience is dynamic, as it's constantly modified over time due to changing circumstances and new innovations. So maybe after a couple of months, when the user finds new bicycle models, his positive experience with his bicycle declined. Other than that, users are different, and so their needs or requirements are also different. For example, this typical classroom chair looks comfortable to many students, but people who are left-handed would suffer using the writing pad that's fixed on the right side of the chair and it's not adjustable. That means that different abilities lead to different requirements, and quality of software systems, just like any other physical products, is highly affected or measured by user satisfaction. In the context of creating software, the term usability represents an approach that puts the user rather than the system at the center of the process. This philosophy, called user-centered design, incorporates user concerns and advocacy from the beginning of the design process and dictates that the needs of the user should be foremost in any design decisions. This will take us to our second point in this lecture, which is how we gather data from users, or what we call user-centered requirements elicitation. Requirements engineering typically consists of these steps: requirements elicitation, requirements analysis, requirements specification, validation, and management. To make it easier to relate user-centered requirements engineering to our previous knowledge of requirements engineering, let's take a look at this figure. It shows the mapping of usability activities to general development activities. With a closer look to the analysis phase of the software development process, we can see that we may use HCI techniques such as user analysis and task analysis in achieving requirements elicitation and analysis. Again, why do we do this? To leverage the usability of the software system and consequently leverage its quality. Remember that many software systems are delivered but never used, and one reason behind that is that their requirements do not take proper account of how the social and organizational context affects the practical operation of the system. The value of user-centered requirements elicitation is that it helps discover implicit system requirements that reflect the actual ways that people work rather than the formal process defined by the organization. Examples of requirements elicitation methods are ethnographic observation, focus groups, and pilot studies. Ethnography is an observational technique that can be used to understand operational process and help derive support requirements for this process. To apply ethnography, first, you need to identify key stakeholders, also known as participants. Second, you should set primary focus. You may prepare from literature, informants, experts, or interviews. Then, decide on observation techniques. Observe group behavior by taking notes on activities at specific locations. Notes concerning the activity's description, goal, frequency, duration, and so on. Also, you should prepare supporting materials. For example, develop field notes collection tool, either paper or electronic format, with timestamp, predefined categories, and descriptive notes. When you observe or interview stakeholders, do not assume you are aware of the details of how they conduct their different tasks. An analyst immerses himself or herself in the working environment where the system will be used. The day-to-day work is observed and notes made of the actual tasks in which participants are involved. At the end, summarize your collected data according to the primary focus and compare data from different methods. This is important because ethnography focuses on the end user, and so it's not always appropriate for discovering organizational or domain requirements. They cannot always identify new features that should be added to a system. Ethnography is not a complete approach to elicitation on its own, and it should be used to complement other approaches, such as use case analysis. To learn more how user-centered requirements engineering is used in real-life example, let's explore this case study. This case study is about the design and development of accessible chat using user-centered requirement engineering techniques. Chat is a tool that's really useful in communicating with other students or teachers in e-learning environments. However, chat programs cannot be used by everybody because of their accessibility barriers. Creating accessible software is important to avoid the barriers that students and teachers experience. Previous research has detected accessibility problems, and one of the most significant problems that people face is related to follow the flow and rhythm of the conversation. Learners with dyslexia, for example, have some problems in the interaction as he or she might not be able to follow the conversation because the other user is writing quicker. Even foreign students, according to previous research, could have flow and rhythm problems because they need more time to think in their native language. This is a picture for Braille display that's widely used by students with severe visual impairment. They access chat messages by touching and feeling dynamic Braille characters that are automatically rendered and refreshed. Because of the available technology, students with visual impairment could have flow and rhythm problems as well. Gathering requirements starts with defining the main users and stakeholders who use chats in mobile learning. The study focuses on people with disabilities who might be able to communicate through text conversations without having problems related to vocabulary or sentence structure. Thus, people with severe cognitive disabilities or people with hearing disabilities were not considered in the study. Then, semi-structured interviews were conducted, followed by questionnaires. The questions were asked for 1 hour, and they were related to personal data, technological preferences, and the problems that participants face when they use chat programs. Questionnaires in software engineering development, which follow a user-centered design approach, is useful for obtaining the user's opinion based on their needs and experiences. After collecting the questionnaires, the data was analyzed to check whether the data was robust or not. Here is another set of data collected about users' mobile devices and the assistive technology tools they use. This picture shows how screen magnifier looks like, which helps us infer why users may have flow and rhythm problems. Users were asked about the main problems they face when they interact with chat programs. They could select barriers from the list provided in the questionnaire or specify other accessibility barriers that they found. These barriers were: I cannot identify the colors and shapes, there are icons which I do not understand, I cannot follow the flow and rhythm of the conversation, the icons are really small, I cannot write quickly, and there are images without alternative text. The answers to these questions are shown in this figure. It can be observed that people with visual impairments experience more problems when they use chat programs. These problems are related to the flow and rhythm, use of colors or shapes to identify information, images, icons, or buttons without alternative text, or the use of small icons. On the other hand, the people who experience the fewest problems are those with hearing impairments. After collecting all these data, how we can analyze them. That's what we are going to discuss next lecture. Next lecture, we will continue discussing further stages of the requirements engineering process. We will explain the HCI methods that can be used in requirements analysis, specification, and validation. Please read these papers before next week so you'll be ready for the discussion. You're also asked to answer this question and submit it on Blackboard by next week. If you have any questions, I'll be at my office at these times. You can also contact me with email. Thank you.